We're going to talk a little bit about electric fans here. So I'm doing a video on my 66 Mustang and the fact that I'm going to add an electric fan to it and get rid of the mechanical fan. Um, and originally I was going to use that part of the video as the beginning because I talk about some really good information there. Um, and in selecting what fan I was going to put in that would fit, um, I decided to order two different fans to try because of the space constraints in there. There's only a couple of inches, and that really limits the performance of the fan. Um, so I wanted to go over real quick some info. So I ordered two fans. I ordered a Spall and I ordered a Summit branded fan on a whim because it stated that it was 1400 CFM and the Spall is only rated at 1300. Now, as I've talked about before, a lot of times it's just an advertising thing. They'll tell you something's rated at so many CFM, but they won't give you the curve for it. And so I was pleased to find out that the fan Summit's branded fan is in fact a Turkish fan. I was able to find out what brand it is because they won't tell you. And I was able to pull it up and they do list the curve. So that's actually only the second manufacturer that I've found that lists the curve. And when I talk about the curve, I'm talking about the performance curve for the static pressure of your radiator. You got to think of your radiator as a resistor, just like an electrical circuit. Bigger, thicker radiators are more resistance. That's all it is. And in order to pull through more resistance, you got to have a bigger motor, more torque, or larger blades. There's aerodynamics involved too, but typically with DC motors, larger DC motor, more current, more power. So Spall publishes the curve data, and this is something that I think Flexolite does not do, and that's why I don't like Flexolite fans. They make good products, but they don't list this data. And as you can see here, it tells me everything. So when Spall, oh, by the way, this is in cubic meters an hour, so you got to multiply it by 0.59. So this would be about 1300 CFM, 2200 cubic meters an hour. So they tell you it's zero static pressure, which is not realistic. That'll never happen. That's free flow rate. It flows 2200 cubic meters an hour. And then as your static pressure increases or the resistance increases, you'll notice that the flow rate goes down. Well, you get to 15 millimeters of water column, which you can also convert to inches of water column by multiplying it by 0.4. You'll notice that you get to 15 millimeters of water column, it has zero flow rate. So that means that if your radiator has, sorry, did I say inches before? I've got 15 millimeters of water column. I don't remember what I said. If you have 15 millimeters of water column, you have zero flow rate, which means that fan is not going to do you any good. It means it won't move any air. That's because it doesn't have the aerodynamics and it doesn't have the power to pull through it. Now, the biggest question that comes up is what static pressure does your radiator have? That's a complicated kind of dark art. And there's a really good article on this, by the way, by Versus Engineering. I posted it in one of my videos a while back. Maybe I'll put the link in the description here to talk about that. But there's so much fantastic information in this article this guy wrote. So I suggest everybody read that. But I'll just say that a 4-core radiator is probably going to be around 15 millimeters of water column, right around there. Okay. A 3-core is probably going to fall around the 12 to 10 range somewhere. So I'm assuming that the 3-core radiator that is in my Mustang right now is probably right around 10 millimeters of water column, which means I'm only going to be flowing 900 cubic meters an hour. That's like 500 CFM. So your realistic or your true flow is actually only about 500 CFM, even though they advertise it as a 1300 CFM fan. It's an advertising gimmick. Now, if you come across a fan that doesn't have this data published, don't buy it because you don't know what the curve is. Unless they say it's 5,000 CFM, then it's probably going to work fine. But it gets really complicated when you're talking about a fan that's only 52 millimeters wide, which is just over 2 inches. because you can't get a big motor in there. You can't get a big motor, then there's, you can't get the torque that you need to pull through it. So, like I said, I bought both because Spall is a really good name. They make a fantastic product. The Summit one, it was a gamble. I was hoping I could look up what manufacturer it is, and it's actually what appears to be a good manufacturer, reputable. It's Turkish, like I said. They also publish their data, so that's great. So this brand is Foz Electric. I was able to look it up and I found it. They make it in a puller and a pusher. So it has the data published here. And what is going to draw me to using this one rather than the Spall, you'll remember on the Spall it said at 15 millimeters of water column, it was 0 cubic meters an hour. So, and also, I think I talk about this in the segment that it'll end up being after this. I talk about more current tends to mean more flow. This pulls about an amp more than the Spall, so this is a little bit higher performance. It's going to move more air with higher static pressure. So I want to use this fan. As to the quality, I can't speak to it just because I've never used this brand before, but it doesn't have an IP68 rating. It looks to be pretty well built. It's not made in China. This looks to me like it's pretty reputable. They probably make OEM stuff, would be my guess. I've never heard of this company before, but the data is here, and this is very important. So it's 3 millimeters bigger, so not very much, but it still will fit. It's going to be, a quarter inch or so away from my water pump. That's about as close as you can get. But the interesting thing is at 0 millimeters of water column, you'll remember the other one was 22, the Spall is 2200 at 0. This one's only 2134, so it's a little bit less free flow, but it has higher performance as the static pressure goes up. So this is a better option for my application, or in general, really. As a low profile fan, I think that this thing's budgeted a little bit better than the Spall is, or it's probably designed a little bit better if these numbers are true. I'm assuming that these are valid numbers. I mean, they don't publish this data without vetting it. So I just wanted to go over this because this is the most misunderstood thing with electric fans, or with airflow or physics. When we're talking about heat exchangers like this is very important to understand this information, because it's not all about what the flow is. It's about what the curve is, the flow versus the curve. So this will be the option that we will be installing in my Mustang. I think that this is probably going to solve my issues. So again, make sure you look at the data. If you go for a fan they don't publish any data other than what the free flow rate is, I guarantee they're going to advertise it as a free flow rate. They're never going to advertise it as anything else. None of them do that. Not even Spall. Spall, you got to look up the cut sheet. That's what this is. These are called cut sheets. You got to look it up, and you got to take a look at the curves. So just wanted to cover that.